The next trigonometric function we are going to show together with its derivative is cotangent z. We have here our function identified as cotangent z. To identify its derivative, let us go away in using with the definition because it would take us a lot of time. Let us use here the derivative or the rule on differentiating a quotient. That is because this function could also be written as the ratio of cosine z and sine z, a quotient of two functions or a rational function. And we know that we have this rule: if k of x is the ratio of m of x and n of x, of course n of x is not equal to 0, its first derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of your denominator, all over the square of whatever your denominator is. Applying that here where our denominator is sine z and cosine z is our numerator, the first derivative of cotangent z would be in this manner: denominator sine z times the derivative of your numerator, which is cosine z, previously identified as negative sine z. So times negative sine z minus the numerator, which is cosine z. What is the derivative of our denominator? Being sine z, we know this to be cosine z, also proven in the previous videos. So you have your cosine z all over the square of your denominator, which is sine z. Now, simplifying our numerator, sine z times negative sine z is negative sine squared of z minus cosine squared of z as the product of these two, all over. I may write it in this manner as still because I would like to come up with some expression later on. When we factor negative 1 on the terms of our numerator, it will become minus sine squared of z plus cosine squared of z. As to why, the reason for that is we cannot find any equivalent form or identity for that, but once we factor that out, this has equivalent value, still over the square of your sine z. Now, what is this equivalent to? That's actually 1. So you have your negative 1 over your square of your sine z. Okay? Now, taking away negative and having 1 over sine z, you have your square. So I move out negative, okay? So you will not be confused with expressing the entire expression by a squared. We know that 1 over sine z is equivalent to, and we have negative again, cosecant squared as cosecant z, which is this form, which is finally, again, a negative is not inside that, so it's still negative square of cosecant z. This is the proof that the derivative of your cotangent z using the rule on differentiating a quotient is equal to the negative of cosecant squared z. Okay? That is now our idea that this is now possible to be used in the later examples. Thank you very much for watching.